In the previous week, we have some pre-session, or our lesson is postponed. But I've shared the total YouTube videos on the internet related to class and its structure. Okay, and so in the previous week we cannot do the same lesson like the classes, but I have uploaded the videos related to class into my YouTube channel. Okay, you can check easily and find out what is gonna be learned in this session. Okay. Have you watched my videos? So in this lesson we will talk about the address of classes, and some classes examples are gonna be performed in this lesson. Okay, so in Python programming language, the class is just a statement, which means that this is either a variable or function name. Or a literal, but dynamically changes. Okay, so in C or C++ programming language, we can create the classes with a specific structure or the properties, but in Python programming language, its class can be considered by is another of the variable or the function name or the anything like that, because in Python programming language we can assign only address of something. Okay, and so if we define any variable, and so we can create the address of this variable, or we can create the class with an instance, and then we can just easily create the address of this class. And so which means that we can assign any class to any variable or the literal or the function name. Okay, and so if the class is interpreted from the Python compiler, and so in the first place we can create the type class objects, which means that every class is a type of the type class. Okay, and so this type class is a parent of the whole classes, which is given in the Python programming language. And so if we can check the class types, and so we can easily see that the type of the class or the class type can be given like in this case. Okay, and so apart from that, each elements defined in the class are stored for the class which you define, which means that if you have any definition related to some specialized class, and so we can define or create the variables or the elements or the methods that containing in the this specific class, which means that we can easily reach the this class or the class properties or the function name by using the class name. Okay, and also we should say that this class name just keep the address of the type object, because every class is derived from the type class, or the type of these terms is the type, and so this type kept to the address. But what is the address? This class name address. Okay, and so how can we prove that what I'm talking about? Firstly, we need to create some examples in here, like this one, the class sample, and there are few, the self, and we can print the foo body. Okay, and so we can print this term with the definition of the sample. Okay, and so the sample is the generalized name of the sample class. Okay, and so what is the type of this sample class? And so if I run this code and then I will get the class type. Okay, and so this type is some type of the class, and so this type is defined with with this property. Okay, this created in the built-in Python function, and so this properties returns to the specific type of this class, because every class is derived from this class type or the object class. Okay, so we know these things, and then we can easily say that it is just an address, and so we can add another variable or function to this class after the class is created. For example, can define the sample class in here like this one, the def foo, the self, and we can print the foo like this one, and we can create another function in here, def b self. Okay, and so we can print the bar value in here, and we can create the sample bar is b. Okay, we can assign that. I'm sorry, this must be removed, and so we can call it like this one. Okay, and so this bar is added to the sample class. Okay, and so if we can create the sample constructor in here like this one, and so we can assign the sample constructor to the new variable which is name of the s, and so as foo can be called, and s bar can also be called in here like this one, but the b takes 0 positional arguments but was given, which means that in the previous lesson we have talked about the self keywords in here like this one, and so if we have this nomination and then we need to add this self keywords in here like this one. Okay, even if this b is the created or the defined outside of the class sample, and so we can easily add another function or another methods or another properties to the class sample by using these terms. Okay, because every class is just a statement, which means that we can assign like the variable manipulation or the function manipulation. And so we can easily assign or add these properties or the methods by using these terms. In C or C++ programming language, we don't have any kind of feature, but in Python we have this feature, because everything is just an address, and so we can translate any address to another one. Okay, any question? Guys, do you understand what I'm saying in here with the class definition? Just react me. Okay. Fatih, Mashat. Okay, so another example can be given like this one, the foo self, and we can call the print foo. Okay, so s can be created by using the sample constructor. Okay, and so we can print the type of the sample in here like this one, sample, and also we can check the type of the s. What about that? Firstly, you need to understand that we have the generalized name of this specific class. It's the parents or the head of this class structure. Okay, it's a generalized name, and so this type returns to the class of type. But If we assign the any variable to the specific constructor, or if we create the what the s variable with the type of the what the sample class, and so this sample class is directly related to what the class of the what the main dot sample. Okay, this is the specific path or the location properties or the scope variable, scope definition of the sample class. Okay, and so this is the instance. This is the what the sample is the generalized name. Okay, just remember that. These two things are different. One of them is the static calling, the other term is the dynamic calling in C or C++ or the C# programming language. Okay, so we can conclude that the class is only represented by data structure that can perform to what some tasks on the common variables which class possess. Okay, and so we can easily set that we can manipulate the any variables that's contained with the what within the class, and so we can manipulate all the variables by using some methods which class possess. Okay, this is the main reason to be utilized to what to class in Python programming language. Okay, so if we have this kind of data structure, we have some specific properties related to what the class definition. For example, one of them is the composition. Composition is that a class object is included in the other class. Then this is called composition. Okay, this is the technical name of the one class object is created or the contained with the other class or within the other class. Okay, and so there are two rules in here like this one. An object composed by a class is only related into one object. Okay, and also we have some difference in here. The runtime life for these objects are almost the same. Okay, which means that we have the two class and one of them is included in the other class, and so this runtime life are equal to each other. Okay, for example, class A can be defined in here, and the def init function in here. This is the standard constructor of the class A, like this one. Okay, and so we can write the print A constructor can be given in here like this one, and also we can give some pass class B and def init function in here like this one, and so this self can be created with a new variable self.a, and so a constructor can be given or called by this initialization function, which means that we can print the b constructor keyword in here like this one. And so if we have the definition of the b class constructor in here, and then we will see that firstly we have the a constructor, because this b constructor calls the def init self body, this function body automatically, and then this function body assigns the new variable in here self.a, and so this is assigned with the a constructor, and so this a constructor calls this definition like this one, and then this definition also printed to the a constructor keywords or the string characters, and after that automatically this print calls with the definition of the b constructor. Okay, this is called the composition of the two class in Python programming language. Any question? Okay, so how can we use this composition feature? For example, we have the square class in here with the pass character like this one, and so we can create the some board or the chessboard by using this square character, which means that if we have the constructor values in here like this one, and so self squares can be defined with the what? With the non-utilization times 8 for I in range 8, which means that we can create the 64 table or the square by using these terms like this one. Okay, so can call the pass and board can be created with the what the board characters in here like this one. Okay, this is the basic utilization of the what the compositions of the what the our Python programming language. Okay, so we have the another terms, aggregation, which means that a class object has another class object, but the lifetime may be different. Okay, this sum of the what the specific characters holds a relation. Okay, we can call it like this one. For example, if we have the class A with the pass like this one, the class B, and we can define the def init function body in here like this one, and so we can initialize the A with the default values of the none, and self.a can be assigned like this one, and so def set A self A can be assigned with the what the self A. Okay, just remember that this A is not a constructor but the name of this class. Okay, firstly, a constructor can be called there's no syntax error in here, and so b1 with the constructor of b, b2 with the constructor of b, and so we can write, and then what, this self a is the what is assigned with the class name, the generalist class name. Okay, and so if we call the b1 set a values with the terms of the what the a, and also b2 can be called with the set a, and then there is no syntax error in here, but this 1a object is used by to another b object. This is called the aggregation. Okay, two class properties is the what are used with the what with two objects or the another class properties. Okay, so there's another example related to this aggregation like this one. We can create the doctor class in here, def init call like this one. This self is this keyword like in C or C++ programming language, and so this doctor is has the arguments of what the name and speciality. Okay, and so we can assign the self name, self speciality. Speciality can be assigned like this one, and this def disp self function body can be assigned with what the f, and so self name can be assigned in here, and self speciality can be assigned like this one. And so also we have the hospital class in here, that the doctors works in here. And so in order to create the hospital, and so we can initialize all the variables with the self keywords in here like this one. But the self doctors should be given in here. Okay, and so def at doctor can be assigned with the doctor like this one, because this doctor is the class name of our properties. Okay, and so this can be assigned with the self doctors. This is the basic constructor definition in here, and so we can append the doctor values. Okay, and also we can display all the variables in here like this one, the for doctor in self doctors, because our list is given in here like this one. This add doctor adds or appends the whole the variables or the whole the doctors into into the hospital class. Okay, and so the doctor dot disp function can be written using using these keywords. Okay, because this doctor possesses this function, and so this function can be called at each iteration. For example, we can create the hospital variable with the constructor of the hospital like this one, and so the doctor 1 can be assigned with the doctor class Mehmet Ali, and for example surgery, and so doctor 2 is equal to the doctor Ayşe Kamil, and this is the nurse, for example. And so hospital variable and add doctor can be called with the doctor 1 and also doctor 2. Okay, this is this is the example of the aggregation, because each elements of the doctor 1 and doctor 2 are used in the hospital class. Okay, and after that the hospital this function body can be called by using these terms. Okay, any question? Okay, so another example of our cases is the vector class representation. Okay, what's the meaning of the vector, or do you know anything about the vector class in C or C++ programming language? Fatih, have you seen this vector representation in the other languages? Okay, the vector is is a specific class that can be added to any variable and possessed by some specialized functions. For example, if we have any vector in here, the 1, 2, 3, I, J, K, there are 3 dimensions in geometric notation, and so how can we add the sum vector to another one? Like the complex number, because each vector has the specific axes. Okay, and so these axes only multiplied or summed with with this axis. For example, j times j is only valid operation in the vector examples. Okay, and so how can we define the vector class? Firstly, we need to give the sum def init function body with with the elements arguments in here like this one, and so self elements can be defined with the what, the elements. Okay, and so this element is created to what, to another variable or the some list or the any other operation in order to what, in order to initialize of your vector instance values. Okay, and so we can give the sum vector, for example 1i, 2j and 3k can be given by using this default constructor. Okay, and so how can we add the some specific order? Just remember that we have the add function. This is the operator overloading mechanism of the what, this of the add the two class values to the another one. Okay, and so we can define the self and other parameter in here like this one, and so we can check the if len self elements is not equal to the len of the other elements like this one, and so we can throw the value error. Okay, which means that the vectors must have the same length for addition. Okay, this only checks to the what, the 1 2 3 1 vector and the other vector 4 5, and so we don't have the z axis in here, and so this is the syntax error. Okay, this just to what, to this operation. But this is not the, if this is not the case, and so the result elements can be assigned with the what, the a plus b. Okay, and so for a and b can be assigned with what, the zip of the what, the self elements and the other elements. Okay, and so the each element is indexed or the indexed by using the zip function, and so this a and b is what, is summation or summed with what, with this operation, and so this list is created to what, to obtain the whole result element. And so after that we should create the what, the new vector in here like this one, which is the class name, and so the result elements can be returned by using these terms. Okay. So what's the meaning of this? The meaning of this is that we can create the what, the vector 1 with the vector notation in here like this one, the 1 2 and 3. This is vector, and so vector 2 can be created 4 5 and 6. Okay, and so we can create the result addition in here like this one, and so vector 1 plus vector 2 can be calling right now. Okay, and so we can print the what, the vector 1 plus vector 2 with the values of the what, the results of the addition. Okay, and so if I run this code and then this result addition returns to the what, to our operation, which means that the main vector object is what is returned in here like this one. Okay, any question? Okay, so these two vectors are summed with another one in here like this one, because of this results element is created with the terms of these terms. But how can we reach the what, the elements of these terms? And so we can easily write the what, the elements of this one, and so this 2 vector 1 plus vector 2 is equal to the what, the 5 7 and 9. Okay, just remember that this result addition is the type is in the class objects, but the elements contains to the what, the list values or the these integer values. Okay. With the same notation we can overload the another properties. for example, the subtract properties. And so this code is the same with the another one, okay, like this one. And so this is the subtraction, okay, and this result elements can be assigned with what the a plus a minus b for a and b into what the zip function, self elements, and the other elements, okay. And so we can return to the what the vector results elements, okay. And so result addition can now be to what, to -1, and so this is the -1. And so if I run this code and then -3 and -3 and -3 to what, to obtain with this definition, because 1 -4 -3 2 5 and 3 6 creates or generates the what, the -3, okay. Or another values can be given in here like this one, def mul or multiplication, self and scalar values can be given in here. The result elements can be multiplied with what, the a and scalar values for a in self elements, which means that each element is multiplied or amplified with the what, with the scalar values, okay. And so we can return to the what, the vector class values with the results elements in here like this one, okay. And so if we have this form, this scalar values, for example 2 and results multiplication can be assigned with what, the vector 1 times scalar, okay. And so this function calls this mul function, which is the overload of our class, and then we can print the what, the values of these terms like this one, the vector 1 times scalar which is equal to the what, the result multiplication, okay. And so this is the what, the vector object blah blah blah, but this, the each elements can be reached with these terms. And so the first vector 1 2 3 and so 2 4 6 is given in this case, okay. Or we can add some specific property in here like this one, def str self, okay. This is the what, the string keyword in here, because we can return to the what, the f vector class values like this one, the self elements, okay. Which means that this vector is written by using this format, okay. For example, if you have this nomination in here like this one, and so vector 1 vector 2 and vector 3 is written in this form, but if I remove these elements right now, and so if I rerun again, and so voila, this vector is written with the what, with this str class, okay, because this is the what, the str is a string nomination in here, and so this vector is overloaded with the what, with the printing operation. And so this result addition is added to this print function, and so this result addition or the address of the result addition does not seen on this page, only given to the what, these formats, okay. Any question? Guys, do you understand what I have talked about? Because it's important, it's the main mechanism of the what, the class overloads or the function definition or the override definition in Python programming language. This is the important part of your projects which is given in the what in the Sunday. Okay. So since this is the error because we need to overload this function. Okay. The Mashat say that the vector 1 2. Okay. And so for example, Mashat, are you asking about these terms? This nomination, Mashat? Huh, okay. And so if I run this code, and then we will get the error because the unsupported operand type for these terms, which means that we overload the mul function, we overload the sub function, we overload the add function in here. But we should also give the what the operation of the division. Okay. For example, div self, for example, other, and so we can print the this is division operation. Okay. And so if I rerun this code, and then this result addition is also given in the what the vector 1 and vector 2 because we don't have any other parameters in here like this one. Okay. And so this function cannot be called in here because this vector cannot be supported by using these terms. Only the scalar values maybe is given in here. For example, the scalar function can be given in here like this one, and 4 can be given in here. And so this is vector 1 is also nothing in here because this scalar is not assigned to the another one. Okay. And so we should overload this function, and so we should also check that this keyword, div keyword in here, this is the operation of the what the R nomination. Okay. Mashat, do you understand what I'm saying? Yes, then okay. Okay. And so this is the important part of the what are class definition. Okay. And so we need to give the these definitions, but we need to understand that every operands can be definable because there is no syntax error, but in the scalar form they could be overloading in here, but in the vector notation we cannot do that. Okay. So we have another example in here for the what for the operator overloading mechanism. Okay. So we can create the advanced math operations library, and so we should give that the class variable to keep track of the number of instances. Okay. So we can give the instance count in here like this one, and so we can count how many variables is created from the advanced math operator. Firstly, as always we do, the initialization function should be given in here like this one with the specific values of these terms, and the return values is the none. Okay. And so self value can be defined with the value. Okay. And then we can increase the advanced math operation instance count with the with the 1 value. Okay. And so this is the constructor of the R method, which means that if any variable is created in here by using this advanced math operation, and then this advanced math operation instance count is increased with the 1 value. Okay. Which means that the 1 variable is created. So We can add the def add and self and other parameter in here like this one. The result, the self dot value plus other dot value can be assigned to the another term. Okay, and so we can return to the what, the advanced math operation with the what, the result value. Okay, or we can define the multiplication overloading in here like this one, the self other, and so the result self value times other value, and so we can return to the what, the advanced math operation in here like this one. The result can be assigned to these terms. Okay, but we may have the some another function in here like this one, the write to file body name. Okay, and so the self and file name can be assigned with this term, and so with open file name the writing format as file, and so the file write can be called with what, the str and self value. Okay, and plus new line character. Okay, and also we should give the def str like this one, and so we can return the str or string constructor can be called in here with the type operation, and so self dot value can be returned by using these terms. Okay, this is the R class definition. Okay, so we can create the instance 1 with the what, the advanced math operation with the initial values of the 5, and also we can give the what, the 3. Okay, firstly the result addition can be called with the what, the instance 1 and instance 2. Okay, and also the result multiplication with the what, the instance times. Okay, and after that result addition dot write to file can be created with what, the math operations dot txt, and also result multiplication we can create the what, math operations or the math operations too. Okay, and so if I run this code, we have the txt file in here like this one. The first time 5 plus 3 is equal to the 8, 5 times 3 is equal to the 15, and so this is the huge advantage of the what, the implementation of the class notation. And so we can create the advanced math operation or the math class by using these terms, and so just we can easily create this variable with the what, the with the summation of the these terms, and so these terms can be called or by used with the what, write to file function, and so we can easily transfer the any data to the what, to txt files or the another format of our results. Okay, and also can create the what, the print instance 1 and instance 2 instance 2, and we can print the addition result addition and multiplication result, and multiplication can be assigned with these terms. Okay, and so if I run this code, the addition result is 8, multiplication result 15, and also we can create the what, the count values of this instance, and so we can write the advanced math operation with the dot operator. We can reach the instance count value. Okay, this is the 4. Okay, because 1, 2, and this result addition is also called the constructor, and the result multiplication is called also constructor by using these terms. Okay, so let's take a break for 15 minutes.